We all want an extra set of hands around the house, right? Having a home robot to load the dishwasher, tidy up, or carry a cup of tea sounds amazing. But as it turns out, getting robots into our living rooms isn't just about teaching them the right dance moves or how to grab a plate. There is a huge physics problem holding things up. The same amount of force a robot needs to lift your dinner plate is actually enough to break a human hand. That is the big hurdle researchers have been grappling with to make robots safe and reliable around our families, our kids, and our fragile wine glasses. Right now, many machine learning trained robots are fantastic at mimicking motions. They know exactly where to put their arms and legs. But they get so hyper-focused on following a specific path that they don't think about the force they are applying along the way. That means if something unexpected gets in their path, they might accidentally damage an object, hurt a person, or even break themselves. The secret to solving this issue is something called compliance. This means teaching a robot not just to track where it is going, but to gracefully regulate the physical force it generates. This idea of compliance goes back decades. Early researchers recognized that robots needed to handle physical contact without causing chaos. They found that a robot could be perfectly stable, moving through empty space, but the moment it pushed on a surface, it could become wildly unstable. Early solutions involved making the machine act like a collection of springs, and later, researchers even inserted physical springs into robotic joints to cushion heavy impacts. Fast forward to recent years, and we have entered the era of AI and learned policies. Researchers are now having robots learn by imitating millions of interactions in digital simulations. Because the real world never perfectly matches a simulation, a new approach called soft mimic has been developed. Instead of just blindly following a commanded motion, these newly trained robots are actually smart about how much force they exert. If one of these robots is carrying a drink and accidentally bumps into the kitchen table, it will naturally adjust and absorb the shock instead of rigidly pushing through it. By collecting hundreds of days' worth of training data in a simulation over just a few hours, robots are finally learning exactly how much force to apply to their physical environment. Mastering these compliant behaviors is the major key to unlocking the true potential of humanoid robotics. It is what will eventually allow these incredible machines to safely step out of the lab and into the delightfully unpredictable environments of our homes.